Okay, so this is an update to Worm, in particular the navigation mesh generation. Now, let's just go ahead and generate a new mesh very quickly, which it can actually go 100 times faster than this, then the game crashes. So, anyway, okay, so just complete it, and then I have to go to number 5. Okay, so let's load it up. Now, in this version we have connections. That's the main thing that was the issue last time, is that there were no connections generated. So it was incomplete. It was just technically a mesh. Now it is a fully fledged navigation mesh. So you can see there are these lines sticking out of the polygon. What that means is that, for example, this polygon is connected to this polygon. And where it draws the line, the beginning, is it's a where the bisector exists, is that means that this is the midpoint of a line. An invisible line segment is somewhere around here. That means that this is the valid way to cross from this polygon to this polygon. So let me show off my amazing MS Paint skills. So you'll have maybe 2 polygons like this, and there will be a boundary segment here like this. If you can go from here to here, it'll have a boundary segment, and the midpoint is what renders. And because they are neighbors, they can. It doesn't matter that we only really need one segment to define the boundary, how to cross from A to B, right? And that's what it'll show. That's what you get. So that's the first thing. The other thing I wanted to show is that so we have our mesh here. Let me add another point here, and let's graft this current mesh. So new block, and then worm continue. Okay, and then we have to, this is on interactive mode still, so I have to keep pressing continue until it saves. Okay, so worm SPL6. Okay, now as you can see, you can see that this mesh, this polygon is connected to the ones down there, meaning it'll flag as a drop, meaning that it has determined that the AI can drop from here to one of these polygons. So another thing, there are miscellaneous connections like stairs like these. This will not be a polygon. This will be an annotation, which is in a future version, which would be the full nav file. That is the navigation mesh plus annotation. This will just be a segment that's flagged as like a climb segment. Same thing for ladders. Ladders are not going to be mesh defined. It's just a marker that's going to mark that. And teleporters as well, and elevators, including elevators that have buttons. All that's miscellaneous stuff. We're focusing on the meat of the matter right now. So let's unload mesh. Now this is what I was talking about before. I think one of them. No, that's not the one. Number worm load 3. Aha. Okay. So if you have in your configuration, if you have use visibility is set to true, what that does is it generates also after generating the mesh. During annotation, it'll also have these yellow segments. What that means is if you have selected use visibility as true, or you can do set var like I did, set var use visibility 1, then what that will do is it'll superimpose a visibility graph onto the mesh, the navigation mesh. Now, there are a few caveats with this. This is a kind of, let's say, a beta version of the viz graph, because what this does is when there is a segment here, a yellow segment, that means that this polygon can see the polygon over here using some boundary where this is the midpoint. The bisector is the midpoint, right? Meaning that, let's say you're over here as an AI, it depends on of course the developer's decision making when doing the traversal algorithm, right? But it's possible, for example, that let's say we have a naive algorithm and the programmer decided, oh, let's just do, when an AI gets to one node, it'll go to the center of the node before going to the next, which is perfectly fine. It works, right? Before going to the boundary. But then let's say that you're an AI and doing that. Okay, then I go here, and then I go over here, if I wanted to go over here. But with the visibility graph, I can just say, oh, I want to go all the way over there. I don't have to have, like, this node has nothing to do with it then, because this is the shorter path, so I just go straight here. So that's what the visibility graph does, is it gives you essentially pre-computed optimal paths. Now, the caveat here is that the current version of the visibility graph will give you topologically shortest paths. What they do not teach you in an intro to AI course in university is that there's a difference between topological shortest path and geometric shortest path. At this moment, the visibility graph is a topological, will give you topological shortest path if you do you do a shortest path search on it, right? It will not necessarily give you the geometric shortest path. Because, well, meaning, like, for example, if you just use boundaries, then the AI will go over here, which doesn't make sense to go all the way over here, even though really the boundary should be somewhere along here. So that will be in the next version. The visibility graph will be improved. But I just wanted to show that. So the visibility graph, you can compute it as part of the Navmesh, but it's not geometric shortest path as of the moment. If you want to manually connect two polygons, which is not recommended, and you should only do this if you're absolutely sure that they should be connected. By the way, it renders the points now. The utility points are now rendered. So if I have these two, actually no, that's not the right thing. Did I clear them? Yeah. Oh no, I didn't. I don't remember how to clear the damn things. Well, it's fine because this is a great example then. I'm going to select node, which selects the node that you're currently in. And then I'm going to go here and say, okay, let's force connect these. Worm force connect. Now you see there's a segment over here. That doesn't make sense. It's supposed to be over here. So that's just shows you that this is no holds barred. It will force connect the nodes if you tell it to. And in this case, it doesn't make sense. So what you can do is remove connection, and it'll remove the connection from it to the selected node. Now let me try that again. Add point here, and add point here, and then do, where'd I go? Force connect. Okay, that makes more sense. So force connect connects the node from the node you're currently in to the selected node. Right, so I'm going to remove this because it doesn't make sense, at least for neighbor connections. Neighbor connections are the white ones. That means it's right beside it, and there's no need to do visibility pathing. What else was I gonna show? I think the other thing is there's another thing in the configuration, save forced, which is if you have added a bunch of forced connections, then they will save along with the rest of the mesh if you save the mesh, which is done by worm. I think save SPL. What number is it? 6? Yeah, that saves the mesh as you have edited it. One thing I need to do is to do force deleted connections. So if you say delete these two or whatever, then it'll remember that you've deleted them, so it won't recompute those connections. That's in a future version. But those are like precision tools that you probably will almost never use. You'll have exported the navigation mesh before that. The other two things I want to show is this. Okay, what you could do also, now that you have this, is you could do export paths, and that'll give you the shortest paths. Where are you? Okay. This will get, so that means that the shortest path from 285 to 279 geometrically, if you don't have visibility graph, is this list of ID line segment pairs. And that's it does that for every node to every other node. So this is every single shortest path that exists has been exported, and this is how you can get it if you want that. The other thing you can do, and this is the main thing, is, okay, this is a fully fledged navigation mesh that if you want to use it in your own project, AI project probably, your own you could do worm export mesh, and what that does is it'll export it to JSON format, which is a list of objects and viewer. Okay, so it'll export to JSON format. In each object in the primary array, you have an ID, which is the node ID. You have geometry, which is the polygon. It's a bunch of vectors. Right? These are the points of the polygon. So the next thing is connections, which are what polygons, what nodes is this one connected to? And the first one, it says, I'm connected to 189 via this line segment. Then it'll have drop. Is it a drop? Meaning, do you have to jump off somewhere to get there? If it says true, then it's a drop. Then viz, if it has viz true, that means it's a visibility edge. It can see it. It's not a neighbor, but it can see it. If viz is true, then you'll have a second line segment here called entry. And let me just explain that again if I didn't. I don't remember if I did. This is node 285. This is the boundary. And this over here. This line segment is the entry. Okay? So the entry is the line segment that it can see of the other polygon. But that's only if you have viz, if viz is true. So this would be, this whole thing then, where is it? This whole thing would be the exported navigation mesh. So if I open this one, which is this, it's just this thing. So this is a visualizer that I made, and you can see this is literally just the mesh-like look. Notice the shape of this whole thing, and then I closed it out. Anyway, so this is just used to visualize what you have on a grand scale. If you have like a really huge mesh, this is nice to look. To find any issues, I guess. So that's updated as well. And I think that's it.